broadcast button on the GoToWebinar control panel to allow all attendees to hear you. This system will notify you once you begin your broadcast. The broadcast is now starting. All attendees are in listen-only mode.
Hello and good morning to everyone. This is Nagarjuna from Surya HANA Academy. So today we'll start a new topic, which is calculation view. I just would like to recap until now what we have seen, all these sessions what we have seen for 5 to 10 minutes, and then we proceed with the calculation view. When we started sessions from HANA, excuse me, just give me 1 second. Is everyone able to hear me? Is everyone able to hear me? And this is our new IP address. One more thing, this is our new IP address. Hope everyone got this details about new IP address and you're able to log into the new IP address. Hope everyone is able to log into the new IP address. We sent yesterday to your email the details. So I'll just show you how to log in. First, as you know, it is same procedure. First, we need to go to MSTSC, click on the remote desktop. And the remote desktop, you have to type in the new IP address. Click connect. Once you connect, it will ask for the username and password. Provide the username and provide the password. Click yes. Once you click yes, now we're connecting to the remote desktop connection. Now once you're inside the remote desktop connection, on the desktop there are two important folders. There are two important folders on the desktop. The first folder is the shortcuts folder and the best details. So once you double click on the best details, so here you can see for all the servers that we have, username and password. And SQL Server details. This is HANA details. This is BO 4.1 and BODS 4.2. And here you have ECC details. And here you have BW and MS SQL details. And here you have BW and HANA details. So once click start, click all program. Just I'll quickly show you for 2 minutes how to log into these systems. Click on SAP HANA, click on HANA Studio, click OK. Double click on the system. Username is best, password is welcome123. Welcome123 is the password, click OK. Now here we log into the HANA system. Double click on the system. So here if you expand the catalog, you can see all the schemas, and then you can expand the content, you can see different packages. So this is HANA system. Now on the other hand, double click on the SAP logon. In the SAP logon, we see ECC EHP7, which is nothing but the ECC system. So once you double click on the system, here you can see the username. Username is best for all the systems. For all the systems, there is username best. Password is W capital. Welcome 123. W is a capital letter. W capital letter. Welcome 123, and click enter. So now we are in the ECC system. S11, and KNA1. So this is on the ECC system. Now I'll just log out. In the same way, you have BW on HANA. Double click on BW on HANA. I'll just quickly show and close this in 2 minutes. So username best, password is welcome 123. So this is BW system, BW on HANA. Systems, status, and here you see SAP BW, service SP74, SP11, which is the latest version, latest service pack. And BW is on the HDB, HANA database. So this is BW. I'll log off. Next, start BODS designer. You have designer. This is BODS. Username is again best. Password W capital welcome 123. Enter. So here you have repository. Just double click on the repository. The password is welcome 123. Enter. So here we are in the designer, data services designer. So we're in the data services designer. And next, let us see the other systems. So we have workbench, data services workbench. All these are part of ETL. So username is best, password is welcome 123. Username is best, password is welcome 123 for data services workbench. So this is data services workbench. Data services workbench. Next, MS SQL. Click all program. Click Microsoft SQL Server 2012. Click SQL Server Management Studio. Now enter the username and password. Microsoft SQL Server 2012. SQL Server Management Studio. The system server name is GNS. Login. Login is the capital letter here. It is caps, BEST, caps. Password is again same, welcome 123, W capital. So now we logged into the MS SQL system. Database, all these are databases. And the last system is BOBI, Business Objects, Business Intelligence. So now we have seen BW74, BW, ECC, SQL Server, HANA, and finally BODS we have seen, and BO 4.1. Click Start, click All Program, click Business Intelligence, click BO 4, Information Design Tool, part of BO 4.1, BO 4.1. Now here we need to add system. So to add system, click Insert Session, and the port number is, I'll give you the port number. The system server details, GNS 6400, username best, password same, welcome 123, W capital. Click OK, got connected to BOBI. So in this way, we have all the details in this notepad. all the details on this notepad. Once you log into the remote desktop, so all these details are there. System GNS 6400 best password, SQL Server details, username best password, HANA details, ECC details, BW74, BW74 HANA, and here you have the access key. Anytime any access key is asked, you can enter this access key. So all the systems are perfectly working, and it has good performance. I hope last week we did not have systems, so you can start working. Everything is. If you have any issues anytime, please do email. So I'll give you an email address for server. There is a separate email address for server. I'll give you that email address. I'll just give you the email address for server. Anytime you have any issues for server related, I'll give an email address. So you can send me to this email. Please send to this email anytime you have any issues. server.suryaacademy@gmail.com. server.suryaacademy@gmail.com. Okay, so let us start a recap of previous sessions, and after recap I'll start today's session. So for the last 2 weeks, we started these sessions for almost 2.5 weeks now. So in these 2 weeks, in the demo session, we started to see what is in-memory, what are column-oriented, what is a parallel processing. And then in the second session, we see how each system can be integrated to each other. So during that time, in that video, we are given the username Surya S capital URYA 1234. It's not S capital, Surya 1234. But now the same details now change it to best. Username is best. The password is W capital welcome 123. For all, it is same user ID and password. And then we started with, in the first session, we started with what is a catalog. Catalog is a collection of schema. Inside the catalog, we have database objects like tables, tables in memory, column oriented. And then we started to discuss about package. Packages are used to group together related information. We discuss about delivery unit. Delivery unit is an object that is used to transport packages from one system to a different system. And then we started to create an attribute view. Attribute views definition. Attribute views are reusable dimensions used to join master data tables. Attribute views have 3 subtypes: standard, time, and derived. By default, every attribute view is standard, time for time-based. We even, on the other day, in the previous session, we created a time attribute and then we joined with the NLT view to do multi-dimensional analysis on time. When creating time-based attributes, the time-based attribute tables are stored in sys_bic. You have different tables. It depends on calendar type. What calendar type, you can get those tables based on the calendar type and granularity. To populate data into these tables in sys_bic, we need to use the option generate time data. And then these tables will be populated These tables can be used to create, these tables are used to create time dimensions. And then we see what is derived attribute view. Derived attribute views are reference attribute views, where you can use this attribute views to do multi-dimensional analysis for a given requirement if the attribute view has same properties, like you want to analyze on AT customer and AT ship to party. Both are referencing to the same attribute view. Template attribute views or copy. You can copy and you can change the attribute views. We've seen about a design time filter. Design time filters are the filters which execute before a join condition. These are the filters which execute before the join condition. We see different types of joins and examples. Text join is a join that executes based on the user session. It gives the language. For the single tables, we cannot execute text join, so we use $language as a system variable. Attribute views, when you activate them, they create column views in sys_bi. These column views execute on a join engine, which is JE. JE engine is optimized to process complex joins with very ease. Whenever you create an attribute view, these are the following steps we have to follow. First, right-click on a package, create attribute view, add tables to the data foundation. In the details pane, create relationship between tables, output required columns, define join types, at least have one key attribute. Whenever you take a text join, take in SPRES, define descriptive mapping or label mapping, activate, validate, activate. Right-click, data preview, perform unit test, check data from source. And these are the steps to create attribute views. Whenever you create an attribute view, a column view is generated. These column views are available in sys_bi. Inside an attribute view, you can also create calculated attributes. Calculated attributes are nothing but you can create calculation between two attributes. For example, phone number and extension number you have in different columns. You can concatenate them. We can also create hierarchies, parent and child relationships. We haven't seen about hierarchies, we will see in the reporting. Why attribute views are called as reusable dimensions is because the attribute views can be used in different analytic views to share master data. So these are the different things we have seen inside an attribute view. Next, coming to the analytic view. Analytic views are the multi-dimensional views. Analytic views are the multi-dimensional views where the center is the fact table surrounded by dimension tables. The limitations of an analytic view, it can have only a single fact table. You can request attributes from multiple fact tables but measures only from a single fact table. When creating an analytic view, two things we have to basically remember, two important things. Analytic views execute on OLAP engine. OLAP engine is optimized for parallel processing of a query. And mass aggregation of data. It can do faster aggregations. We tried to create a scenario to see profitability analysis reports wherein ECC has a T code called K24. In that we can see actual profitability analysis. We created similar kind of report in HANA, high performance. So we discussed a scenario called COPA. What is the disadvantages of existing ECC system? How HANA can take advantage? What is a main car scenario? What is a sidecar scenario? So when creating analytic views, we see data foundation and logical join data foundation. At the data foundation inside an analytic view, you can create a star schema. The same star schema can be created in logical join data foundation. The star schema that you create inside the data foundation is for BW on HANA. You're trying to create relationship between tables physically. These also execute on OLAP, but the only difference is the master data tables, the master data, when you do this kind of modeling in data foundation, cannot be shared. It is specific to that particular model. But in order to share, we create an attribute view. These attribute views can be used as the dimensions when we create star join data foundation. So in a star join data foundation, we reuse the attribute views to create a star schema. When creating star schema in the logical join data foundation, we have other options like creating calculated columns, creating restricted columns. A calculated column, you can derive a new column based on existing columns. Calculated columns are always between two measures. Restricted columns, you can restrict attribute values on a measure. Like if you want to restrict based on year, based on company code, you want to create calculated columns based on measures. You want to calculate net revenue, where gross revenue minus sales deductions. So in this way, you can create calculated columns and restricted columns. You also have one more option called input parameters. Input parameters are where user can give input to the system. You have variables. Variables are nothing but where users can choose the data that they want to see in runtime. They can filter data in runtime. Users can filter data in runtime. You can create variables inside analytic view. So again, analytic views are multi-dimensional views. The center is a fact table surrounded by dimension tables. You can always request measures only from a single fact table. It executes on OLAP engine. It's a multi-dimensional view. We have also seen analytic views when they create column views in the sys_bi. We also discussed one important point. When using attribute views inside an analytic view, attribute views by default execute on join engine, but when used inside an analytic view, they execute on OLAP engine. They skip join engine, they execute OLAP engine, because only one column view is created, and that column view in sys_bi can execute on OLAP engine. And we try to generate various report dimensions. It was very, very efficient when you compare with the ECC. Now, why it is efficient, we know primarily there are three reasons. One is the data is stored in memory, the data is stored in columnar fashion, the views that we create are multi-dimensional views which are optimized for reads, and they execute on very powerful engines like OLAP, where OLAP is very efficient in reading the data for parallel processing and mass aggregation of data. How fast it can aggregate? 15 to 30 million aggregations. What is the scan speed it can do? 3.2 billion scans per second per core. So that is the performance of the analytic views. Extremely fast aggregation and parallel processing of a query. And then we wanted to continue the scenario of the analytic view. We additionally want to see, based on our scenario, we have data in actual COPA table, CE1. We have plan data in CE2. Now what we wanted to do is, we wanted to take actual from actual table, plan from plan table. We wanted to show the variance between them. But in order to show variance between them, in order to show variance between these both of them, can we use both these tables in a single analytic view? Or can I use an analytic view inside an analytic view? We cannot, because that's a limitation. So that's why we wanted to create a calculation view. So today's topic is calculation view. Let us start with the definition of a calculation view. Let us start with the definition of a calculation view. And what are the different data categories inside a calculation view? When to create what data category? What are the limitations of a calculation view? What are the best practices to create a calculation view? That we will see in the entire week. In the entire week we will see. So meanwhile, I also encourage everyone to practice on the new system. If you have any concerns, please let me know. I given the email address server.suryaacademy@gmail.com. First, the definition. I'll start MS Paint. Okay, so first click Start, click All Program, click SAP HANA, click on HANA Studio. Now we log into the HANA Studio first. Double click on the system, password, welcome 123, expand content. Just give me 1 second, please. Just give me 1 second. Thank you everyone to hold. Just there is one issue I need to rectify. The views are not getting activated. We are having some authorization issue. I'm just trying to. Someone has pinged me. Okay. So the first thing that we have to do here is. So once we go to the content folder, right click on the content. I'll just create a package. I've created a package called ECC March 7:30 AM. Click OK. So on this package, I'll right click on the package, click New, click on the calculation view. So let me give a name for the calculation view. CV underscore actual underscore plan underscore data. And click finish. So once I click finish, okay. So let us see the definition. So what is a calculation view? A calculation view can have data sources. Means it can consume data from attribute views. It can consume data from attribute views. Second, analytic views. Third, calculation views. Fourth, tables. So what are the data sources for calculation views? For calculation views, these are the data sources. So attribute views can supply data to a calculation view. Analytic views can supply. Calculation views can supply. Also, the tables can supply. So you can have one calculation view inside a calculation view. You can have an analytic view, you can have attribute views. All these are my data sources. What are the different operators we can have inside a calculation view? What are different operators? We basically have 5 operators. Now, when I created a calculation view, we see join, union, projection, aggregation, rank. So there are 5 operators. What are those? Join, second, union, third, projection, fourth, aggregation, fifth, rank. So what are the data sources? Data sources are, all these are my data sources for a calculation view. All these are operators I can use inside the calculation view. Join. Join is a query based on a condition, like inner join, left outer join, right outer join, referential join, text join. So any of these joins are basically a condition. Join is a query based on a condition. Union. Union is to combine the results. You want to combine data from C1 IDA table and C2 IDA table. You can do union. Projection. Projection is used for a selection of columns. You can do, for example, you have 100 columns in a table. You can select the required columns from a table. You can do filtering. You can do calculations, like you can create calculated, restricted. You can create design time filters. You can select required columns for output. All these things can be done inside the projection. Fourth, aggregation. Aggregation is how you would like to summarize measures. How you would like to summarize a measure. For measures, for amount and quantity related data, the aggregation type by default is sum. For example, 10 USD plus 10 USD plus 10 USD is 30 USD, or 10 USD plus 20 plus 30, 60 USD. But from 10, 20 and 30, which is the minimum value? 10. Which is the maximum value? 30. What is the average? So in an aggregation, how you would like to summarize a measure, whether you want to use minimum of all the values, whether you want to use maximum, whether you want to use average, whether you want to use count, whether you want to use summation. So aggregation is nothing but how we would like to summarize a measure. Rank, how we would like to rank data. For example, top customers. So join is a query based on a condition, union to combine, projection, selection, filters, calculations, aggregation, how you would like to summarize a measure, rank. You can rank data. So these are all my data sources, and all these are operators I can use inside a calculation view. Next is data categories. What are the different data categories I have inside a calculation view? What are my data categories? 1. Dimension. Second, cube with star join. I'll take cube. Second is cube. Third, cube with star join. So these are my different data categories, and these are my different operators. So this is nothing but the definition of a calculation view. So calculation views are used to join, union, projection, aggregation, rank, different data sources like attributes, analytic, calculation views, or tables. There are different data categories inside a calculation view, which are dimensions, cube with star join. Means you can use any of these sources of data, you can use any of these operators by using these data categories. Now, each data category has best practice to create a calculation view. When should we go for a calculation view? When should we go for calculation view data category of type dimension? When we should create calculation view of type cube? When should we create calculation view cube with star join? On the other day, on the last session, which is on Friday, we discussed one scenario. The scenario is we have two analytic views. One analytic view is AN underscore COPA underscore actual underscore data is one analytic view, and the other analytic view is we copied and we had plan COPA data. In here the table is C2 IDEA. Here we have C1 IDEA. So finally, from here and from here, the measures are VV010, VV070, and the measures here VV01, 0001, VV07, 0001. So this is my gross for actual, and this is my gross for plan and sales reductions. Now what is my requirement over here? Here I have one analytic view, and here I have another analytic view. Now how do I achieve? By using a calculation view, I want to produce a result that actually can combine both C1 and C2 table. so that I can see all these four measures. I can see all these four measures in a single calculation view, and thereby I can create a variance, actual minus plan. Actual minus plan, I can create a variance. So this is one analytic view, this is second analytic view. I want to combine both these analytic views in a calculation view. I want to see the variance between both of them. Because other than a calculation view, I cannot combine two analytic views. So if I want to design something like this, now based on the definition, based on this definition, what is the data category I need to choose? Okay. So if you have the requirement like this, so what is my requirement here? In my requirement, I have analytic view 1, A and 1. I have analytic view 2. Okay. So analytic view 2. So whenever you have analytic views, whenever we have analytic views as your data sources, whenever you have analytic views as your data sources, which produce data, which provide data to a calculation view, then the data category is a cube. Whenever you have an analytic view that produce data, means this is a data source, means a source of data to a calculation view, then the data category is a cube. So if you want to create this scenario, so what is the data category I need to choose? I need to choose the data category as a cube. Why? Because the data category cube can use the data source analytic view. Because I want to combine, I will use union operator and to create a calculation view of type cube. So when data source is an analytic view, when the requirement is union, the data category is a cube. Because you have analytic views. And these operators can be used in any of these data categories. And there are a few best practices for it. We can use any of these operators, but when you have an analytic view as a data source, we have to go for cube. Now, I'll try to explain what are these data categories and when to choose what. First, we'll start with dimension. Dimension. So what is a dimension? A dimension is basically nothing but when you deal with master data, whenever you deal with master data tables, is nothing but a dimension. So whenever we deal with master data, it is a dimension. So in a star schema or a cube or a star join, these are nothing but the dimensions. And this is where you have measures, nothing but transaction data. We have transaction data over here and you have master data over here. So To design this master data, nothing like company code, customer, material, time. To design this master data, there are two ways in HANA. There are two ways. One is you can create an attribute view. You can create an attribute view. Attribute views are nothing but dimensions. Also, we can create a calculation view of type dimension. So, dimension modeling or master data modeling in HANA, master data modeling in HANA can be done in two ways. One is using an attribute view and the other one using a calculation views. So when it becomes a dimension, nothing but you're actually dealing with master data. So when you're creating when you're creating a multi-dimensional view, when we're creating a multi-dimensional view, the dimension over here you can create as an attribute view or you can create as a calculation view of type dimension. So until now we only know the dimension can be an attribute view. But now even a dimension can be a calculation view. Okay. In what scenario should we choose attribute views? In what scenario should we choose calculation views? So simply to say, a calculation view of type dimension data category deals with master data. Just like how an attribute view is providing data to an analytic view, a calculation views of type dimension can provide master data when you have cube with star join. So what is a star join? A star join is a multi-dimensional view. So there are two places we can see star joins, one in the analytic view and the second one is in the calculation view. Star joins can be seen in the analytic view and in the calculation view. When you create a star join in an analytic view, what is the object that provides master data? Attribute views. When you create a star join in an calculation view, what is the object that provides master data? Calculation views of type dimension. So there are basically a dimension modeling in HANA can be done using an attribute view and a calculation view. Attribute views provide master data to an analytic view. Calculation views of type dimension provide master data to cube with star join. Hello? Is everyone able to hear me? Is there some issue with the audio? Yeah. Because I got a message that my voice is breaking in between. Voice keeps breaking in between. If that is the case, I can use the alternative connection. Okay. I think because other participants are able to hear me properly, probably the bandwidth from your side is little less. Please check from your side. Okay. I'll continue the session. So calculation views of type dimension. A dimension is used to model master data. The master data modeling can be done in two ways. One is with attribute views and the other one with calculation views. Attribute views are used as master data modeling inside an analytic view, and a calculation views of type dimension is used as a master data to supply master data to calculation views of type cube with star join. So now, do we have a clear picture on what is the data category we have to use? This is only for master data. When you use data category of type cube, when we use data category of type cube, when we use data category of type cube, when we use data category of type cube, it means that we can use all these data sources. We can use all these data sources. We can use when we use dimensions. When we use dimension, this is for master data. When we use calculation views of type cube, we can use all of them as data sources. We can use all of them as operators. We can use all of them as operators when creating a data category of type cube, a calculation view data category of type cube. So whenever you have a requirement, okay, join tables or union to analytic views, or use an attribute view or an analytic view in tables. So you can use any of them as data sources by using these different operators to create a calculation view of type cube. Now, cube with star join. Now, cube with star join has limitations. The limitation is, in a cube with star join, the limitation is we cannot use attribute views. We cannot use analytic views. We can only use calculation views and tables. We cannot use attribute views and analytic views. We can only use calculation views and tables. We can use all of these operators inside a cube with star join. So cube with star join doesn't permit to use analytic views or attribute views as its data sources. It can use all the operators. Cube, you can use all the operators and all data sources. Calculation views of type dimension. This is especially to create master data. And calculation views of type dimensions provide master data to cube with star join. How an analytic view provides master data to, how an attribute views provide master data to analytic view, calculation views of type dimension provide master data to cube with star join. So these objects, when we create, it means that we are creating cube with star join. Now, why we have to go for a cube with star join? Cube with star join has a very good performance. Cube with star join has a very good performance. It does better join determination technique. It has a better join determination technique that is introduced by SAP in Service Pack 8. Before that, we did not have this concept of cube with star join. It is only released in Service Pack 8, where to give very good performance for calculation views, because it can take shortcut to data based on a query. It can take shortcut to data based on a query by using specialized techniques. It has a better join determination technique. Whenever you execute queue with star join, this model executes on a special engine. This model executes on a special engine called SQL engine. It executes on a special engine called SQL engine. Now, how many different kinds of engines we have? There are basically 4 different engines. What are those? You have join engine, you have OLAP engine, you have calculation engine, we have SQL engine. When should we use join? Who uses join engine? Attribute views. Who uses OLAP engine? Analytic views. Which object use calculation engine? Calculation views of type cube. Which engine use SQL engine? Calculation views of type dimension of type cube with star join. So these are the different data models, and these are the underlying engines that each data model exploits. Each of these engines have a specialized capability. Join engines are optimized to process complex joins. OLAP engine optimized for mass aggregation of data, parallel processing of a query. Calculation engine to perform complex calculations like calculated attributes, currency conversions, unit of measure conversions. Cube with star join, SQL engine, has a better join determination technique. So each of these engine join for complex joins, OLAP for mass aggregation of data, calculation engine, complex calculations, SQL engine, faster execution of a query by using better join determination technique. Okay, now the point I'm trying to make in this session is there are basically 3 important points. Point number 1, what is the definition of a calculation view? Calculation views can use all of these as data sources. These are different operators inside a calculation view, and these are different data categories. Now, when to use what data category? This is for master data. The master data supplies to a cube with star join. When to use cube with star join? For better join determination technique. It executes on a specialized engine called SQL engine. When do you go for a cube? We go for a cube when you have all of them as data sources, because a cube with star join doesn't permit to use attribute views and analytic views, but we'll also have a requirement we have to use all of them. In such a case, go for data category cube. So that is for today's session. So the important point is when to use what data category. This is for master data. This is for all the data sources. Cube with star join is for faster execution of a query, better join determination technique. Cube executes on what engine each of these views execute. Cube execute on C engine. But dimensions and star join execute on SQL engine. Analytic views execute on OLAP. Attribute executes on join engine. And all these engines, all these data processing engines are inside index server. Index server is a server where data processing is done. Inside the index server, these are the different engines that are actually taken care by different views inside SAP HANA. So just I want to highlight 2 points. What is a calculation view? What is the use of each data category? And what are the engines that it processes? So now we'll see the questions here. I'll read out the questions here. So whatever the data models we created until now, you'll have in the same package. The first question is, where can I see the old data models? So because this is a new system, I'm going to create in the same package. So you'll have all the data models in this package. You can see tomorrow. So all the data models, I'll recreate them in the same package by today. So you can see all the previous data models in this package. Second question. In an analytic view example, you use a standard attribute views. Yes. We can also use derived attribute views. Yes, we can use derived attribute views. But you use derived attribute views when you have the same requirement, but with a different name. I'm activating an attribute view. I got an error. Grant select privilege on a schema of the use data foundation table to user sys repo. So can I know what schema are we using? When we're actually using the tables, what schema are we using? So basically, if you can tell me the data model, I'll do a quick check. But let me take some of the models anyone created here. For example, please see you're using from a different schema. So you can use the tables from the schema best. Then you won't get this error. Because all the schemas may not permit us, I'll just because we may not have privileges to use all these schemas unless and until the administrator assigns object privilege on that schema or on the table. Only when we have, we can actually but you can see now I just created one view. I can go back to the package. So I just create one view here. I create an attribute view. Yes, I create an attribute view. A data preview. I just want to show the view will get activated. So we can see data. The view only will get activated. You should have the privilege on a schema. If you have a privilege, then you can use. So what I recommend is for now, you can use all the tables in the best schema. So after this session, I will populate all the tables in here, our examples and all the tables in here. So there are basically two things I'm going to do. The first thing is in the best schema, all the tables that we are using for exercises, MARA, KNA1, T005T, 5U, all these tables I'm going to keep in best schema. The second thing is in the ECC March 7:30 a.m. batch, I'm going to recreate all the data models that we have seen until now. So these two things I'll be doing from my side for tomorrow's session. I mean, replication of tables, I'll do it immediately. Data models, it'll take some time. So by afternoon, you can see the data models. So let's go to the next one. So what is the best practice to use cube with star join? Is it an attribute view or a calculation view as a dimension, and why? Cube with star joins are basically used for analyzing transaction data. These are mainly for operational reporting. When you have main car scenario, whenever you have a main car scenario, when you want to do reporting on operational data or a normalized data models, these are normalized. Normalized data models, we use cube with star join. But please wait for tomorrow's or day after tomorrow's session. We'll see more in detail. Because at this point of time, I don't want to confuse. So give me tomorrow's time. After that, I will explain more details by tomorrow once I complete this topic. So what are the best practices to use calculation views or tables in cube with star join? We can use tables and calculation views inside a star join, but we should not use analytic views or attribute views. What data sources does what data sources does dimension data category use? Yeah, dimension data category uses tables. It uses the base tables where master data is residing. So next question, as you upgraded to SP11, so do you have to recreate these views again? Yes, because I did a system refresh. So what happened is I completely taken away the previous data models because we started with a fresh batch. I thought there are a lot of data models that are created in past. I want to eliminate them for which the batches are already completed. So there are batches which have taken 1 year back and 2 years back. So I don't want to keep them. I only want to keep the fresh ones. So that's why I'm recreating them again. So in a calculation view, does dimension data category use attribute views with master data or just master data tables? Just master data tables. It doesn't use attribute views. It only uses the master data tables. If attribute views are used in dimensions, it means cube with star join use attribute views, right? No. So attribute views are used inside an analytic view, but cube with star join cannot use attribute views. If you still technically you can still drag and drop. If you drag and drop, what happens is internally when you see something called visualization plan, it is to see what engines is processed on what engine, what data is processed on what engine. It skips the engine. It skips the attribute view. So always best practice to use calculation views of type dimension inside cube with star join data category. So we will see HANA architecture in the next week. In the next weekend, once we complete calculation views, then in the next weekend, I'll tell you all different services we have in HANA and the architecture of SAP HANA. Like what is index server, what is preprocessor server, what is statistic server, what is access engine, what is daemon. All this, there are different services. So if you see, if you double click on the instance, so there is a question, can we see HANA architecture? So we'll see there are different services over here. We'll see about each service, why it is used, for what it is used. So as you said, tables, but the data source we have are attribute views, analytic views, etc. No tables. I do not understand the question. As you said, tables, but the data source we have are attribute views, analytic views. No table. Okay. So data sources tables means here. Please see here. May I mean to say that we can use these tables. You see, in a calculation view, I can just drag and drop this table here. So even this table also becomes a data source. Means it is a source of data. Means from this table, I can use data to supply data to the calculation view. That's what I mean to say when a table as a data source. I mean, like how you take attribute view, entity view, I can directly take tables also. That's what I mean to say. Okay, then from my side, I'm going to replicate these tables and create views. And any other issues, please check from your side and please do email me. Thank you so much to attend today's session. We'll see you tomorrow. Have a good morning, good evening, and good night to everyone. Thank you.